How do you dress the electrodes and change the tips, or are you gonna get to that?
Yeah, okay. So, dressing electrodes. That's what we're gonna learn now. I did it. This is an electrode dressing tool, okay? It just ovals it out so it's about a 1/4 inch diameter like what we got. This machine doesn't have a tip dress valve, which is a valve that turns the air off, keeping it up, and the tips just drop together, and then you can ratchet, clean those electrodes, just like that. And these get to be pretty aggressive. Sometimes you'll find a little pile of copper on the floor there because people like to just keep on going on it. And now you can see it's got a little edge to it. And you don't want to rub your finger on that, so you got to either use a radius file or just a flat file. Just get rid of the sharp stuff. And then you're good to go again. And remember, as soon as that tip mushrooms out, we get a weak weld. And we keep letting it get bigger and bigger, it's going to be weaker and weaker. And it'll show up when the customer gets their parts, and somebody will get a rejection notice, and then chaos starts.
Should you measure your tip face every once in a while?
Yeah, you can. And measuring that, you can make a tip gauge out of aluminum, so that lower or upper electrode fits right in an 1/8 inch piece of aluminum. Okay, you contour that hole, so when you check the tip, if it doesn't fit in there, it's time to dress it. And that's what a lot of people do, or they just take that ratchet thing and clean it up. But that's the best way to do it. You can make a tip gauge, hang it off of here on a piece of wire or chain, and then the operator checks it every 50 parts or 100 watts, depending on how severe it is. If they don't have water flow, it's going to mushroom out much quicker. If they hammer it down too hard, it's going to mushroom out. Okay? If we have too much pressure and we weld that and we still get that burn mark, it may look good, but what happens is too much pressure makes such a good tight connection, the current goes from one electrode through the part into the other electrode, and it looks like a good weld, but it isn't. That's why you have to check your work.
I'm gonna go backwards for a second. Sometimes I see you use a file and emery paper, emery cloth instead.
That, if this was too sharp, then I'd take a file right here, and then I'd put that in there and dump the air. This would be more for like aluminum, if we were welding aluminum, or if we had to make our electrode face bigger. So right there, you can twirl that around, and doing this, each tip gets nice and flat to be against each other. So if we had to have a 1/4 inch flat, we spin this around and then put the air back on it. Okay, so now when we dress that, we got file marks in there. I think I got it. So we got to use a little piece of emery. I usually have some here, just to smooth that out. Because if the electrode's too rough, every time you weld now with that rough like that, steel or aluminum, whatever you're welding, is going to collect in those file marks because there's a gap. If you go to weld and you got a tip that's like that, in between each one of those file marks, material is going to collect, it's going to arc, and pretty soon your tips are going to stick together, and then you really got to do some dressing. I know I had a piece here.
Yeah.
You got some?
You used to keep strips of that.
Yeah, I know. I used to have it on there. Trying to clean that up.
Yeah, there's some down here, Dave.
Is there? Oh, there it is. Okay. That stuff looks kind of wore, so.
Will you show the camera how you wrap it around the file?
So what I do is wrap it around the file like this. The
What
center will be nice and flat, but when the tips come in, it's going to dent that padding there. So it's going to address the radius of that electrode also.
What grit is that?
Oh, this is 240.
Is that about,
240 or 180 is great. If we were doing aluminum, you'd want 320. Because remember, all them little lines in there are going to collect. If we had 80 grit here, and we went to weld aluminum, the tip would be coated in about 5 welds. So now this is going to be nice and smooth, and we'll get a better weld. Quick disconnect there. Well, now you can see it's nice. If you don't get all that grit out of there though, it's gonna, whatever's on your tip face is gonna transfer to your part. If you got a big scratch in there, and you're welding stainless, it's gonna show up.